to get up there and it's not me.
I've been to Framingham. I'll talk about your project. Yeah.
Hi. Nice to meet you in person. I think it's fun.
Oh yeah, you're definitely going next, buddy. You're definitely up.
Oh, it's me?
Yeah.
All right, well.
Whoa, whoa, whoa.
1 minute warning. We got a 1 minute warning.
You should tell Allison about her cup.
Oh yeah, Allison. Yeah.
Oh, and they said don't do it, I assume.
And you're a New Yorker. I actually thought it was funny.
Okay, well, I'm gonna go jot down the list.
Oh, like too much content? Too much intensity. Yeah, that's true. That's true. I like to also think people like if they were there, they remember. So or I just okay, yeah. Okay. So but how many minutes? Good morning. We're going to get started. So good morning. Welcome. My name's Laurie Kokkinides. I'm with the Department of Public Service, and I have the honor of moderating this panel. The group here will review current 10 activity and share their experience as some of the people engaged in these initiatives. So first up is Needham.
All right, good morning. My name is Needham. I'm the Director of Thermal Solutions at Eversource Energy. My slides here. So today I was going to talk a little bit about our pilot project in Framingham. And this project's a couple years in the making, and we actually have 2 winters and 1 summer under our belt of operating the network. So I'm going to focus kind of on the data collection, some operational considerations that we saw this winter, which were challenging, and kind of focus on a couple different things besides legislation, and my colleagues will cover that. A little bit about Framingham. This project is really came out of our natural gas rate case a few years ago. Eversource operates in 3 states, New Hampshire, Massachusetts, and Connecticut, and we operate as an investor-owned utility, natural gas and electric distribution, along with electric transmission. So this system here, it's about a mile of pipe around a neighborhood in Framingham, Massachusetts, which is a small city just west of Boston. So there's about 140 customers or end users on this loop, mostly residential, some small commercial, including a fire station, school building, as well as Framingham Housing Authority, city-owned building. So we'll talk a little bit about design, data collection, research, and what we saw, as I mentioned. So really, this project is to prove out, can this work at utility scale, kind of first in the nation project at utility scale. So a little bit about monitoring, data collection, and research. This is a shot of our pump house. So that's sort of the main brain of the system. That's where kind of the action is. Maybe some of you have been out on site, a tour, you might have seen this building. And that's what it looks like in the winter. You know, how do you get to it when you get snow and things like that? But there's monitoring of the network itself constantly from here. So we do have data on how the system performs, the network, pressures, temperatures, et cetera, constantly. On the customer side, we have Frontier, who's a third-party firm. They collect data at the building level and are really studying how that energy moves in between all the homes. Then Heat, the home energy efficiency team, they are studying the actual capacity of the bore fields. We'd have 90 bores here. They're across 3 separate bore fields in the system. So how did we do this winter? This is a snapshot in a chart year over year of the temperature within the system itself. So good news is the system works as designed. We always were within the temperature range that we expected. So the engineering, it works, which for the engineers in here, no surprises. But when we're out there operating it, like a real concern for us is like, how is this thing really working? It was the coldest winter in 15 years, right? Lots of snow. This is a really good sign. So year over year, didn't see anything really fluctuate. We do have a backup boiler in the pump house. Proud to say we never had to turn that on once. But in the event that temperature does get too low, there is some redundancy there. We have never had to turn that on in 2 winters. The low temperature this winter on the loop was just about 41.78 degrees Fahrenheit. And that was recorded when it was 8.9 degrees in ambient air temperature. 24-25, we reached a low of 41.02. And that was when the ambient air temperature dropped to 13 degrees Fahrenheit. So similar performance. My last note here is really around operational models, you know, for utilities. This project moved from pilot, design, science experiment to real-life energy delivery system. People are counting on us, right? The system now can't go down. It needs to be monitored, and things need to be responded to. So if you're thinking down the line how you will manage this with your staffs, I urge you to give that some thought. We have a small but mighty team working on the project, and then we have a broader operations team in electric and gas who think this is neat, but is a side project. So that's kind of what you might face in your own companies, you know, at a utility. So give those things some thought. Occurrence tracking, we track just about everything, and with good reason. You know, we kind of split these up into 2 categories. One, which we label behind the meter. So think of that, in this pilot, Eversource actually owns the HVAC equipment, and things go wrong, right? There's things that can happen inside someone's home that we are responsible for, which is not our typical business. And then there's just loop side issues, which we track. So most of the issues that we face, or occurrences and alarms, are inside people's homes, which is a challenge because now we got to get through their front door. And they got to be home and want us there and work in their home. So that's just a split of what we're facing. The second piece of this is, where do these occurrences happen? Right? Is it residential? Is it commercial, et cetera? Most of it's residential, which shouldn't be a surprise. Most of the customers are residential customers. 10% of these are at the pump house, just alarms and sensors, really, things rotating, a pump off, things that we have to monitor and make sure that are real, and we may need to respond to make sure the system's operating as it should. 6% are bore field, a lot of sensors there measuring the bore fields. So again, just something that pops up, we look at it, respond, make sure everything's working. 2% are commercial and 2% are municipal. You know, really those are error codes on HVAC equipment, whether it's a freeze out or something that's happened there with condensation and the like. And then, you know, the bottom note here is roughly 8% of these occurrences are just quote unquote nuisance alarms. They're not truly anything that we need to respond to after we investigate it. This is just a snapshot of a couple of sample customers and their monthly heating bills over this winter. So we have one customer on natural gas versus GEO, and that customer one actually saving about $13 a month over the winter with this geothermal system versus their pre-pilot rate. So kind of expected it to be even. You know, the whole thing for us was that, okay, it needs to be even with natural gas likely, and this is a really nice story. And then the customer number two is the GEO pilot versus oil, and that customer saved actually about $202 a month when going with geothermal compared to home heating oil. You know, this to me really is what customers are caring about. They want to understand not only how the system will perform, but what it's going to cost them. And affordability, you know, being what it is, top of mind in our service territory and mostly across the country now in terms of energy, we think there's a compelling story here to make this more affordable over time. So just some general takeaways, you know, from my folks. You know, from a technical perspective, there's a commissioning component here. We learned some valuable lessons in commissioning this network, mostly around chasing air pockets, and there's changing topography along the loop, a little hill here at a high point. So just learning that within the commissioning process is important. So we added new protocols that try to address that for future expansion of that loop. Proactive customer education. This one probably can't be understated. This is really important. You know, talking to folks in, you know, just in the last session are things like customers really need to understand this technology. And if you're going from oil boiler or natural gas boiler to a geothermal heat pump, you need to retrain yourself on how the thermostat should be set, right? In New England, we like to jack it up to 72, turn it off. Well, that's not exactly how these systems work. They need a nice little range to operate on. So we needed to really educate all our customers on how to utilize these things properly. And then challenges of behind-the-meter work. In aging building stock in Massachusetts, most of these homes were built in the 1930s or 40s or even before. Weren't exactly designed with ductwork in mind. A lot of them had forced hot water systems. So that retrofit, we ran into just about everything, right? Asbestos, mold, all sorts of installation challenges in retrofitting these homes. Not that they can't be overcome, but they need to be acknowledged and addressed. And then really coordinating with homeowners. You know, when you have a project like this that needs to come together kind of in harmony, folks need to be available, around, and willing to do it at the same time. And that just in of itself can be a challenge. Lastly, wanted to just highlight some customer survey data that we had recently, and this is, you know, we don't have a huge sample size out there, but this is really encouraging to us. And we surveyed, really focused on cooling. And, you know, a lot of the homes on this route didn't have central air before, and now they do. And last summer was warm. Maybe not the hottest one on record, but it was hot. And that was a huge benefit to these customers. And a lot of us were thinking, oh, heating. Do not lose sight of cooling and the value to your customers as part of one of these projects. So most people were very satisfied. That's great. We know who the red ones are. We know who they are. They voice their opinions early. They call us all the time. But most people are happy. They're happy with their comfort level. They're happy with what they have. And, you know, team's done a tremendous job just making sure customers understand. But the summer value of this can't be understated. Just a few verbatims from that survey. You know, folks are thrilled. Most everyone gave kudos, and there's two comments here. Central air was so nice, right? That's not about heating. And then another one here was about someone not having to put a window AC unit anymore. They actually got light in that room. And, you know, little things, little adjustments to the home can go a long way. So in great comments, we have a couple of our folks get mentioned in here by name that really supported the project the whole way through. So lastly, any resources go to the website, give us an email. We're around to answer questions. And about the pilot, we're hoping to expand off of that as well going forward. So that's all I had. Thank you for your time.
That was great. We've been waiting 2 winters for that. My name is Greg Koumoullos. I'm Department Manager at Con Edison. For the non-locals here, Con Edison, we're also an investor-owned utility operating gas, electric, and steam in New York City and surrounding Westchester area. We're at an interesting point where we are right now, and this presentation and really the structure of it is really a good sign of the differences of kind of where we are. I'd love to be able to share tons of facts with you and stats and charts and graphs, but we're not quite there yet in the operation. But what we are, and I'm going to get to soon, is where we are in the learnings. We've learned a lot that we can learn before building it, and we're going to see it come up here. First, before I do that, I do want to thank Eversource and everybody associated with what happened in Framingham and that project. I mean, all those teams, Heat, all of them, the work they did set us up for where we are today. So if you look at the time chart there, that doesn't look as pretty in that background, does it? That looks pretty not so nice. That's okay. We'll work with it. So really, it started for us in 2022, right? You heard about that, silly UTENJA name acronym that we heard, but that's what kicked utilities like us into gear and the Department of Public Service into gear and figuring these out. And that's when the law was passed, the order came on board, and then we had proposed projects. As you can see, so 2022, we're in 2026 now. It's been kind of 4 years of development and learnings, and I think those are very important, and they're important things that we learned, and I think we've evolved our thinking. I made a comment earlier, if you were here a year ago, almost every comment was about natural gas utility perspective when it came to TENS. And every comment I've heard so far is about electric now. And I think that we've evolved our thinking as a state and as this industry of where the benefits of these really lie. And you saw it here in comments made not by electric utilities, but by everybody else talking about these. And you're going to see it in some of the lessons we learned. So first I'm going to talk about is a little bit of early, even the slide order got screwy. Okay, I'll talk about this now. We'll talk about some of the early engineering and financial modeling. So one of the important things here that we got to do because of that timeline was fully design a project prior to it being approved for construction. So what that means, at first it sounded kind of crazy, right? So we proposed these large projects, $100 million plus, and it was just so novel and new that it made sense for our regulators to break it up a little bit and figure out, what is it really there, and is it worth the investment to our customers, which will be funding these, right? Because in New York State, it's not that these were funded by anything other than the same customers like myself that pays a Con Ed bill every month, right? So it's important that we're using it wisely. That being said, because we had these rules, we got to actually fully design our projects. And that was very important because when you start looking at the energy modeling, and that was something that we learned early on, if we have a couple of our engineering consultants here, part of our contracts did not involve a hard emphasis on energy modeling early on. Yet it was a huge pain point later when the designs were done and we had to kind of put this all together of really where are those benefits coming from. So one recommendation to people designing this is, build that early, get the energy modeling right, because when you have refined, good energy modeling with good assumptions, not blanket assumptions that mess everything up, then you can do early financial modeling. And at the end of the day, these only make sense where they make sense financially, right? Both from a utility, from the regulator, from the customers. So you can't get to that good financial model unless you have a good design and a true energy model that looks at real costs, what they are going to be. Let's see what slide comes next. Okay. Customer stakeholder. No worries. We improvise. All right. Liam talked about the engagement with stakeholders. That comes at every single level. So in a project that we have, for instance, in Mount Vernon, which is a project very similar to what you saw in Framingham for Eversource, we had to talk to everybody, right? From customers to the city of Mount Vernon to their policymakers to their public workforce, understanding what this is, what they are, how to use it. It was a huge learning curve. The same was true for very complex customers like Tishman Speyer and Rockefeller Group and related. Although they know about in theory, how some of these systems work, they didn't really understand what we were trying to do as the utility. And that took a lot of work, and that took a lot of meetings. I remember the first meeting we had with one of those building engineers in Midtown Manhattan, even just explaining to what it was, he was ready to like shut us down and not listen, right? And then suddenly he became a champion of this, right? Sharing it with other buildings up and down the Avenue of the Americas of these projects, right? So that turnaround comes from really working hard up front. That's where you get the trust, and then incorporating their feedback. I'll give an example. We were in the Mount Vernon project. One of the early sustainability commissioners said, we need to meet them where they are, right? And you should have, encourage us. Have a town hall meeting in the rec center that you're going to work on. Show up at our City Fest, right? Talk to the customers where they are, and hear what they're concerned about. And it wasn't necessarily what we originally had in our script to talk to them about, right? It was about those simple things like, what does it work today, and how does your heating work today, and what's working well and what's not, and how are we going to protect you? And that's important. And incorporating that feedback, that's how you build their trust. All right, a whole slide got eliminated, but I was going to talk to it at the end of this one. There was a question earlier. Somebody had a question about rates and billing, and I'm going to address it now. So these are new, and if you're doing a utility doing these, it's not just a matter of is it electric or is it gas, or it is something totally new. It is thermal. And there's no agreement. There's no script for this. There's no thermal agreement today. We have electric tariffs and gas tariffs, but we had to create these agreements, and that took a lot of work up front, and it was actually in the creation of those documents that we realized things that we had to design in our design, right? So if you need to monitor and measure certain items, you have to have that in your design. So you can't wait to the end to do customer agreements, right? And that's something that we worked on really hard. Some things are you can kind of set the stage for, so our residential agreements we were able to fully create, and all these are available. If you click on the link on the postcards left of the tables there, you can see what's public, and those are out there. But some of them are very complex. A customer agreement, that's a very complicated customer, like you heard about Rockefeller Center in one of our projects. It took a lot of work on trying to get term sheets that we could agree on the use of their equipment, the use of our equipment, how that looks. And you have to invest equally into all of those items because every customer is different and they have different needs. The rate design itself. So we heard different options. So one of them was flat rate. So like Eversource had a flat rate, right? I believe, nominal fee, I don't know, $10 to $15 a month, something to that nature. And that for small residential customers makes sense. If you look at a larger customer like Tishman Speyer, which is going to be our supplier of waste heat for our Rockefeller Center project, it takes effort to give us their waste heat from their system. It's not free. Like, we first thought that maybe like waste heat's free, like they can just give it to us, right? And they'll be happy to get rid of it, and we're helping them. But the reality is that it costs them almost nothing to get rid of the waste heat in the winter out the atmosphere, right? That waste heat, that heat is hard to get rid of in the summer, but it's easy and cheap to get rid of in the winter. So it actually costs them money to give it to us. So we have to compensate them for that money, and it has to make sense for them, especially in pilots, to want to commit to doing such a risky project. So that's something that we learned, and that's part of the value. We had to understand what those customers are, and you have to understand, all right, they're investing their money to a certain extent. They need a reasonable rate of return on their investment to even get the capital on their end to invest on their side, and then we have to make sure that whatever we're paying for that heat is compensating them for that. Now that cost for that energy is then a pass-through cost to the customers. So the customers need to be able to, it has to be comparable to what they're paying today, right? So you can see these becomes quite a complex financial models and negotiations that you have to go through. But it's all part of the early design. Again, I'm not talking about this is how the winter was last year. This is just in the development of these projects. And if you don't look at them from all the lenses, you tend to find holes in the projects that end up biting you later on. All right. There was a slide that I'm going to just talk to that has some good points, and she didn't tell me to sit down yet. So the first slide I had was about project selection, which is kind of silly to talk about at the end. We took an interesting route, and it's something that worked, I think, very well, and we found it to work well for Con Edison. There were some mentions earlier this morning about an RFI, a request for information that we did on a separate effort having to do with transmission reliability. We did the similar items for the U10 project. So when this law came about and the PSC order that came soon after that, it said, give us a project and, yesterday, right? And that's good, but it's challenging, right? So when you do that, you lose some good things, right? And one of the things that we realized that let's not rush. Let's put out an RFI to the market and let's see what the market has in mind, because the market's been thinking about this longer than we have. And we actually got 8, different unique projects that came from that RFI that we were able to evaluate, and different innovation of solutions. We had sewer heat recovery that came through it. We had data center heat recovery. We had one pipe systems, two pipe systems, campus systems, SUNY systems, a variety of different geothermal projects all kind of came in, and then from that we were able to build a balanced portfolio to say, what do our customers look like, and let's find a project that best fits each type. So we have a project in Mount Vernon that's dense suburban areas with smaller residential and smaller commercial. We have a project in Midtown Manhattan, right, which reflects a big part of our customer base, and then we have a project down in Chelsea, Lower Manhattan, that has a very large residential, right? And New York City Housing Authority facilities that are there. So when you look at those projects, that's a good approach. The other benefit to that approach is that you're getting stakeholders that want the project. And I'll talk a little bit about this. So when we went to Mount Vernon, they knew nothing of this, right? That project was actually cited from a leak-prone gas pipe replacement site that a study was done back before 2022, back in 2019, to see how could we retire that section of leak-prone pipe and get those 8 or 9 customers off the main. And we saw that, and we said, well, that's a great opportunity to let's expand on that. Now that a 10 is a thing, and see if we can expand it. And it was a great opportunity. But those customers and the city had no idea what it was. It took endless amounts of work by the teams here, and you could talk to them, Janana and Brittany, and the kind of teams that are here that that worked on the ground of being there every day in the field, knocking on doors, talking to people. It was a tremendous amount of work, which came with a tremendous amount of skepticism, which was just because customers just didn't know what this was. When you talk about the other sides of the portfolio, the larger customers through the RFI process, Tishman Speyer came to the table saying, we want this project. We have an idea, it's in our buildings. Related came to the table with their buildings. These collective projects helped you because now you have customers that want the work, right? Now you have a party where you're not trying to convince them and teach them what this is and try to show them how it will benefit you potentially. You have stakeholders that come to the table. So my recommendation to anybody starting these is go and find a way to get to the market and have the market come to you with interested parties. That makes the journey a lot more manageable to get to where we want to be. And that's my first slide, but my last slide is, again, I intentionally left technical things out of this because I know the information's there. Thanks to the structure that we have, with our regulators and the way it's structured, all the project information, all the lessons learned are available. They're on our website. They're on the docket, but they're linked right to our website on the postcards on the table. I welcome you to take a look and then ask tons of questions once we get to the Q&A section. All right, we're good on time. All right, I'm going to ask Holly to come up.
Oh, I was just taking notes of all the good things you said. All right. There we go. Hello. It's very nice to be back at New-York-GEO. It's been a year and a half. I'm Holly Braun with Northwest Natural. We are a standalone gas utility in Portland, Oregon, so John wanted to have the other coast represented, so it wasn't all just East Coast here. We do not have a project complete, but it's fun that we actually have legitimate lessons learned that we have learned from others and applied to our project. I think you'll hear some of those, but then also some I feel like that we have learned and are happy to share as you all are figuring out how you advance your thermal energy networks. Let's see. This is a service territory map and a sense of our scale and size. We have a unique situation in that our 14,000 miles of distribution pipe has all been fully modernized. So there was a big effort from 2000 to 2015 to do that. No more cast iron or the bare steel and cast iron. Now it's all poly pipe, yeah. And so we do not have the same financial argument when we're looking at putting in a 10 because we already have tight modern pipe. So just kind of have that in the background as you're thinking about this. We're in a mild climate, which means we don't have the extremes, and I had thought, oh, GEO's maybe not as good of a fit for us, but we actually have really balanced load, so the heating and cooling being balanced is helpful, and also high soil conductivity, which is also helpful for GEO. None of these projects pencil without the carbon mandates and some kind of monetized value carbon, a price for carbon. And in Washington State, we also have a TENS bill. So that legislation actually paves the way for us to go about doing these projects in a way that we do not have in Oregon. And most of our service territory is in Oregon, but we can't really do TENS. We could maybe shoehorn it in. We haven't tried to do that with that price per ton of carbon. In Washington, it's much more straightforward, so that's the project I will speak to you about. I don't expect that you can read the detail on this slide, and that's okay. I will orient you, but if you start at, think of it like Michigan, if we were on a country map, that City Hall is the white rectangle there in the middle. That is an existing building. This, everything else is new construction, and this is in Vancouver, which is just north of the Portland border in Washington. When the bill passed, one of the city members actually called me and said, hey, we saw this bill passed. We'd like to work together and see if one of the sites that we're looking at developing would be a good fit for the project. And it's come out already, and actually this will get into the lessons learned, but to have that internal champion, somebody who's already excited about this, is really huge for the project. So we said, absolutely. And we just needed to find one project. We didn't have to find the best project. We needed to find a good project, and we needed to move fairly quickly, so it was nice to already have them at the table. So City Hall is existing. They have a ground source heat pump, and then the 3 kind of shaded buildings are new with a parking garage. There is one more up to the far end, but that one is on its own timeline, and we were not able to connect that into the 10. What all do I want to tell you on here? The purple lines, I wanted to tell you that these are all mixed-use multifamily, and the date you see is 5/13 when we turn this in, and in the meantime, this is the downside of new construction. What is actually being built, what is planned to be built, has shrunk, and it's now 2 buildings. So the stats you see on the side are updated for the new numbers. City Hall is still there. The 2 mixed-use multifamily buildings will have a total of 315 units, and half of those will be affordable. And then you can see the square footage for commercial on the ground floor. This will all be open loop with Geo Exchange, and every unit will have its own ground source heat pump. And we've had to go through the analysis that you just heard about. Well, how do you set up the rates and the pricing in order to do our filing? And we have set it up so that these customers will pay what they would have paid for their bills if they were using air source heat pumps, which is what would have been built, if not the ground source. Gas was never envisioned for this area. The funding, in the old design, looks like it'll be about $13 million. About $13 million. Some of that will be covered by a grant from the state of Washington, anticipated. Of course, the investment tax credit, and then the TENS customers will be contributing, like I said, what their bill would have been with air source heat pumps, but that's not enough to cover the whole of it, so then the gas customers end up paying the balance. The purple line is where you see the shape of the 10, the thermal energy network. We were trying to find the balance between, if you build it smaller and tighter, it's cheaper, but then it's harder to expand. So trying to find the balance between expandability and low first cost. And then the orange is going into each of the buildings and the heat exchangers. It's harder to see, but there are 2 sets of wells. This is all open loop, so we have 2 extraction and 1 injection well on each side of the property. So it's just like a feel for our site. And now the lessons learned, the fun part. Okay, engage with the legislators early if you get the opportunity. We were able to say, well, actually, we were able to take some of the information from Eversource. They said, well, what will it cost to build a thermal energy network? I said, well, that's based on, there's so many factors. So let's figure out a couple anchors, and then we'll give you a very rough number. But I remember calling Eric Bosworth in a quick order and getting some numbers. But engaging if you get the opportunity, and don't resist. I don't know, every utility is probably in its own spot in terms of if they want TENS legislation or they don't, but our take on it was that, well, we did want this. I was already very excited about this before the legislation, but then if you work alongside them, things usually go easier for you, and we ended up with many fewer thou must and many thou should consider. We targeted new construction. You heard from the previous speakers. There is a lot of work of getting everyone signed up within the network. We know that we will need to do that as TENS take off and we do more and more of these. But on these first projects, the first project, we've had the philosophy that let's walk before we run. Let's start something simple. We already had the partner in the city, so we wanted to work with that. And I'm sorry I failed to mention the partners at the top of the slide, but I think we'll keep going. Solace was on there. I don't know if they're in the room, but Solace is our design engineer. So lower costs up front, fewer decision makers, and we really needed to move fast with the timelines in the bill, so that felt appropriate from that standpoint as well. Talked about this one. And then I feel like the biggest learning that I would want to pass on that I feel like worked well for us is think like the regulator. Think like the regulator. They haven't regulated these before. This is hard, this is new. At the time this passed, our commission was going through a lot of scandal. So I was concerned they might not even pay attention. I mean, they just were so busy. They have so much on their plates. TENS comes through and we don't have to do it. It's all optional. So will they even give us, will this ever raise in the priority? So we had all of that in mind and worked first with all of the other gas utilities in the state of Washington to get on the same page and make sure we had the questions ironed out. And we were trying to be as clean and organized about this and come forward with one set of questions, one set of philosophy, and all of that to try to make it easier for them. I think actually, so yeah, coordinate with the affected utilities. And excellent, we'll have no problem meeting the 3 minutes. Coordinate with the affected utilities, and we actually set up a technical working group so that we're meeting every month with the Department of Commerce, who's issuing the grants, the other utilities, the commission, of course, and we're using these as learning sessions. And the idea is let's all get smarter together. We're saying this is new for all of us. Like this is hard for all of us, but it's going to have a different angle on why it's hard. But let's get smarter together and let's learn about a thing in a different setting than we make a decision about a thing. Because it's just uncomfortable. We're not making our best decisions if we've just learned and now we have to regulate or make a big decision. There is something else on this. Sometimes notes are good. Coordinate with the affected utilities, regulators' shoes. Oh, I know. It should actually be a bullet. I was really concerned about not actually, like, when are we going to be able to meet with the regulators? And if they like this, if they understand it, if they want this to happen, that was going to make a big deal on how everything else went. So we had our first meeting where we actually brought in the representative who passed the bill or had written the bill, drafted it, along with all the utilities, all the stakeholders, and he's the one that presented it, and we talked about it. So we're all in there, kind of eyeball to eyeball. We're seeing and hearing the same thing, and it set the tone for what we wanted to create together. And so having it start that way, I feel like was a good, getting their attention. We're all in the same room. We've all got a different angle on this that we need to lean forward in to help manifest this. But that seemed very helpful in us then getting their attention and the future meetings. And they have been amazing. So here's my little kind of proof / kind of the outcome that we've gotten to so far in this process. We just submitted, we didn't just, we submitted our rate case, and then we submitted our rate case, and the staff then give their recommendation to the commissioners. And they heard and understood that we're working with, even though our bill doesn't say thou must on very many things, there is a whole laundry list of things you have to consider. And so when we write our testimony, we need to say, here's how we considered, here's why we did this, we want to walk before we run, just so many things. And they basically echoed our words back to the commissioners as their recommendation. And so I pulled out a little excerpt, and they acknowledged the net result is a challenging scenario and a set of priorities that compete with one another. The commission is left to choose between those competing priorities and associated costs. To paraphrase the late all-time great Mr. Rogers, today's word for the commission is trade-off. And I thought that was really good, that they recognized this is difficult and that we need to be really practical about this. And it ended up that our rate case settled months early, and the TENS was part of that, so we're feeling really good about it. Thank you.
Hi, everyone. I'm Allison, Considine. Just want to say thank you to NY-GEO for the opportunity to be on the panel, and thank you to my co-panelists for those awesome presentations. I'm with the Building Decarbonization Coalition. We're a national nonprofit focused on accelerating the transition of buildings away from gas and towards electrification, and building the coalitions and tables necessary to get all the stakeholders together to advance durable, equitable building electrification. So I'm going to talk a little bit about the evolution of utility TENs and TENs in New York, and some of the political coalitions that have come together to drive this forward. It kind of transitions nicely from what Holly was queuing up there in Washington. And then queue up some of the projects that are in process in New York, and then zooming out to some of the national landscape on TENs legislation and what's been moving forward in states outside of New York. So how many folks here know about the Utility Thermal Energy Network and Jobs Act in New York? Okay, most, but not all. So UTENJA, as Greg said, the nickname we use for it because it's kind of a mouthful, was intended to remove the legal barriers to utility development of thermal networks and require the Public Service Commission to direct utilities to commence thermal energy network pilots in each major utility service territory, as well as developing a regulatory structure for utility thermal energy networks to scale affordable and accessible building decarbonization, protect customers, and also to create like really high quality, timely, reliable transition pathways for the folks who've been working on the gas system to use project labor agreements, connect apprenticeship programs to actually have those union workers developing thermal energy networks in New York. And some of those aspects really speak to the coalition that helped bring the bill forward. So Climate Jobs New York is now also integrated with this coalition, but really a lot of credit to the leader of the United Association of Plumbers, Pipe Fitters, Steam Fitters in New York at the time, John Murphy, who sort of recognized that the next 100 years for the members in his union weren't going to look like the last 100 years, and some forward-looking leadership and thinking about there's a lot of energy in New York. We have a very vibrant climate movement, a very vibrant environmental movement, and at the time our All Electric Buildings Act was moving forward, and folks were really trying to find where is the center of the Venn diagram of the interests of environmental justice groups, environmental groups, labor unions, in building decarbonization, and how can we kind of leverage some of the unique capacities of utilities, their access to capital, their access to the right-of-ways, their experience developing managing large infrastructure like this to meet the interests of all these different stakeholders. One kind of interesting aspect about UTENJA, it really encouraged looking both at geothermal and beyond geo, at waste heat recovery and heat recycling. And I think this kind of speaks to those electric side impacts that Greg was talking about. So it encouraged ambient temperature loops. And as we've seen in some of the projects that have emerged, there's everything from waste heat capture with data centers or sewage treatment plants, sewer main heat recovery, as well as just capturing heat in the buildings and recycling it to move forward. So this map shows some of the utility thermal energy network pilots that have been proposed across the state in yellow, and then also some of the public campus projects. So since we're talking about North American TENs, I kind of figured I would take it beyond utility and think about some of the other places innovation has been moving forward here in New York. I know Carter from SUNY's in the room, and the SUNY campuses and public campuses and public buildings have really identified an opportunity to lead by example here in decarbonizing their operations using thermal energy networks. And SUNY Purchase, SUNY Oswego, SUNY Binghamton, University of Buffalo, University at Albany, these campuses have been drawing down money that's been allocated in the budget for thermal energy networks to actually decarbonize their operations. And I think the timing couldn't be better. An example that stood out to me in a recent conversation with SUNY Purchase's energy managers, a lot of these campuses were developed many decades ago. Their current heating systems are at the end of useful life. They lost heat for several days this past winter from that existing natural gas powered system, which is obviously not good for students, not good for classroom learning to not have heating. And so they're really seeing the opportunity to meet their climate goals, do building electrification, but do it in a way that reduces the impact on the electric grid and actually sets them up to be kind of learning labs of innovation in the state. And I think what's exciting about that is, while there's obviously differences, we're talking about a single building owner for the campus, and so there's fewer regulatory hurdles for them to clear. I think having these campuses move forward, even as we're awaiting the next steps on the utility projects, kind of showcases how the market is getting ready for this, how much enthusiasm the legislature has for this, and how much New York can be a leader on this, not just on the utility side, but in looking at how these systems perform in our cold climate state with some constrained electric capacity downstate and obviously rising demand on the grid across the state. So one thing I wanted to highlight with those public campus projects is Colorado Mesa University, so not New York, but I think the benefits here speak to why all of these campuses in developing their clean energy master plans landed on TENS as the solution they wanted to pursue. So this system serves 17 buildings and about 11,000 square feet, provides heating and cooling and domestic hot water, and in 12 years of operation, they've never had to rely on their gas backup that they built in. It has extremely low maintenance costs, and they've saved $12 million in energy savings since 2008. So I think that opportunity to actually really reduce over the long term the O&M and just the cost of energy, and getting off kind of the roller coaster of volatile, fossil fuel markets that are, as we're all seeing, we're at the mercy of global politics, and that's showing up in people's energy bills. It's showing up in how much it costs to run a campus and how much students get charged in tuition. And so that's really, I think, these kinds of success stories where we're seeing this isn't necessarily new technology. It's being deployed in new ways, but it has been working, it has been successful, and it has delivered significant energy and cost savings in other parts of the country, and that's why public campuses are pursuing it here. So to kind of go to the national perspective, I think, initially, like 2021 to 2024, we really saw utility transition laws be the kind of first driver of states prompting utilities to propose thermal networks. So in addition to New York's Utility Thermal Energy Network and Jobs Act, Minnesota's Natural Gas Innovation Act, Maryland's Warmth Act, the Mass DPU approving Eversource's geothermal pilot, all kind of were embedded in the idea of how do we move a utility-scale gas system transition, particularly in these states with robust climate goals and frameworks. And this was sort of one of the main policy motivators for moving these forward. As this has developed and gained momentum nationally, we've got a room full of people talking about this, which maybe wouldn't have been the case 6-7 years ago. We've seen the question shift to how do we finance and scale thermal energy networks. Connecticut has authorized a grant loan program. Illinois has allocated $20 million for thermal energy networks, utility and non-utility. Texas has qualified thermal energy networks as public improvement projects, which passed unanimously. And really this framing of, they can deliver long-term affordability, they build our resilience, both of the energy system and reducing strain on the electric system. They create jobs and a union career transition pathway. And they leverage, the expertise and skills of local drillers and local oil and gas workers towards the green transition. So like I said, I think we're kind of shifting from can utilities do this to how do we finance and scale within and outside of traditional utility models. And I would just highlight that really across the country, this remains bipartisan. We're seeing support at the federal level, at the state level, and I think we're going to see more and more kind of enabling legislation moving forward across the state, and a lot of states looking to New York for how to do this and how to make sure that, as these are moving forward, we're capturing the data and the learnings and making it as accessible as possible so that this can be successful going forward. Thank you.
Thank you, Allison, and the entire panel. Very exciting projects and information sharing here, so I appreciate the presentations. I think at this point we're going to open up for questions.
We got 12 minutes.
Any questions?
Hi, Joanna with PSE&G over in New Jersey. PSE&G is seeing an affordability crisis, but also the need to increase grid capacity. How did all of you manage to convince your various regulatory bodies to come to a conclusion about how to do this? New Jersey doesn't have any current legislation around TENS.
I don't think this will be a full answer to your question, but it's reminding me something that I should have had a note on. We actually we're a standalone gas utility, but we worked with the electric provider in Vancouver, and they had a methodology to calculate what the energy would have cost with air source heat pumps versus ground source, and they have committed to an incentive and also testified for us on the savings that represents from an energy efficiency and a capacity standpoint to their grid. And that ended up a pretty compelling point at different spots where things were looking shaky on the cost side when they were able to vouch for the savings on the electric grid.
Thanks, and I'll take it to this step. So, we haven't convinced anybody to do anything yet, but what we have shown our regulators is that, we're taking this seriously, and we're putting top-notch talent from our company on this, right, and have been dedicated to work alongside DPS along the way to learn and make sure that what we're putting forward, we're putting that affordability into perspective. So we're not putting things forward that don't make the most sense. This way, collectively, the best educated decision of strategically how to move forward on these is taken. So I think that's the advice I'd give, is to work side by side with your regulators in that, because it's a learning part and we have to learn together.
Yeah, I think in our pilot, we probably didn't have to convince on affordability as much as we would have to now. And we're cognizant of that, with an expansion on the horizon and a filing for new construction projects to put boundaries on financial impacts to customers. The grid impact itself, I think what's going to unfold over the next couple of years and unfolding now is non-gas pipeline alternatives and integrated energy planning and modeling out the benefits to the grid so that they're understood and that everyone's really gets that, us, the regulators, customers.
Just to kind of play off Liam's point there, in New York, it costs about $3 to $6 million per mile to replace a mile of gas pipe. And we're seeing, an increasingly constrained electric grid. And so I think when you look at increasing capacity prices over the long term and the impact of the grid of an air source heat pump approach versus a networked thermal energy network approach, figuring out how to capture those costs, those avoided costs, is going to be where I think the real opportunity is to look at this not just as a standalone project in a vacuum, but a project that can help us avoid even more expensive upgrades in other parts of the electric and gas system.
Yeah, Bob Wyman here. Question, first, it's been fascinating watching the industry, go over the last couple of years, from small buildings to big buildings, from neighbors sharing loops to campuses, and now we're formalizing the TEN and the U10 technology and understanding what thermal energy networks are all about, where you can share the energy between buildings. And I hope this isn't too soon to suggest this, but I think we also then need to think about the next step. What happens when we've got a lot of TENs and we want to say look at them together? I think on the electricity side, we learned about virtual power plants, where it was useful to have a lot of otherwise disconnected people to manage to control them as a single unit and present them to the utility, to the grid as a single unit. I wonder if we don't have a similar opportunity here that we ought to be thinking about, although right now we're still trying to figure out how to do TENs, where what I would call a thermal aggregation network, where the value is coming not from networking the energy, but from basically networking the control. So we'd have then TANs and TENs just to make the words a little bit more complicated. But I'm wondering if we did then start thinking about a thermal aggregation network where we've got a large number of buildings, maybe mixed in with a couple tens, or a large number of buildings on their own, or even just a set of tens that are physically disconnected. I think, you know, the interesting question is, what could that do for the grid? What are the opportunities for using those systems as demand response resources, for instance? I think, was it Liam? You know, Eversource mentioned that traditionally we've always wanted geothermal systems to run sort of dead flat, not to change their temperature up and down. But if you want to have demand response, you probably do want to change the temperature. So in a future world where we have tens, where we have tans, et cetera, where we have this large thermal resource, what potential do we have to provide dispatchable demand response? Or are we stuck with always wanting to have these things produce constant load?
I'll take a big picture stab, and I think it goes back to some of the comments that we heard from Laurie this morning about the orchestra and where these land, right? So I think a couple years ago, and I agree, we've been down a journey, these seem like gas system replacement projects. And that's how they were kind of first, at least how I first heard them from what was going on in New England. And I think that we've collectively evolved into that in order to make something that's so unique and upfront, you know, somewhat expensive, valuable, is understanding exactly what you're trying to unpack, right? Which is, what other value streams can we get from this? And that comes from being able to do just that, right? To be able to find the right place for them. I think if we start thinking about these networks as tools, and I'll be quite honest, tools for our electric grid, that's what they are. Or especially in New York State, when we're not doing new construction for gas, I think there's a value. If you have a new development that you can extend gas mains to, then there's definitely offset value there. In New York State, and specifically even New York City, right, legally now, that's not an option, right? So the value of these really looks at it at our long-term, looking at our electric system. And I think that's where all those come into play. Once there's some tens on the market, which there aren't too many right now yet.
Yeah, I don't think we've thought about the TAN concept probably as far as you have. We've had discussions about the expansion and what disparate systems might look like and the benefit of having those and an overall benefit to the grid. But it is something we probably need to start considering if we're going to build this out, you know, one block to the next, how it really works and what the true benefits are. You know, there's tons of planning and engineering components that would need to go into that. So you'd be looking at the folks in this room to probably bring those concepts and ideas forward, you know, to us or others across the country to bring those ideas ahead.
One other piece I would add here is, you know, and UTENJA kind of directed especially a look at ambient temperature loops, and I think some of the benefit of that is being able to have a really high degree of interoperability and scalability and have different thermal resources that may emerge in the area, be able to plug in and exchange heat and cool with the network. So, you know, if you have maybe not a data center right now, but in the future, some kind of waste heat generator like that, setting up a system that can accept different kinds of load and sort of play into reducing that overall capacity strain of all of the utility customers in that section.
Hello, my name is St. Williams. I'm working with Scottish Development International, which is kind of the trade and investment body for the Scottish government. I'm here in the States. I'm based in Boston. And I think my question is probably more so directed at Eversource and even Edison, like up to the pilot piece or even the learning that Edison has been doing, kind of like looking at the Framingham project. How much learning has been taken from maybe international cases in the UK or even in Europe? And then in terms of like potential suppliers, vendors, or even stakeholders over there, how much kind of interaction has there been when it comes to knowledge sharing?
Okay. I guess I'm going first. You pass the mic to me. We have. So, one of the first things that happened is we realized that these are not new. The existence of something that you want to call 10 or district energy, right? And it's not necessarily new even to us here, right? Our district steam system is a district energy system, Gen 1, if you want to call it that. We've been doing them, but they're in different situations. So at first we looked at Eastern Europe, and those systems went to district energy years ago. They took out the coal in their individual homes a long time ago, 40, 50, 60 years ago, and went with the fossil fuel-based district energy. And what they're doing there is they're trying to decarbonize those district energy systems today. All right, kind of similar to what we're trying to do for our Kokkinides and steam system now. In Canada, we work very closely. We even had a peer engineer work on our projects that did a lot of work in similar type of systems for the last 20 years up in Vancouver area of Canada. They did this more like the Holly's model, right? Where let's look at new developments, and what they did really great there is they work with city planning. So the city planning and the municipalities are planning are putting a 10 requirement into that planning. So when you have a new development, you have to be, let's say, 10 ready, right? And they used the government bonding to help that. And that was very knowledgeable, and we learned a lot from that. I think what we're closest to right now is actually the UK. I think the UK is similar to us, where they didn't build long district energy systems like they did in Eastern Europe. They actually are more like what we are today, and they're trying to retrofit. And maybe they're a few years ahead of us. They're doing some pretty good things with waste heat recovery from the tube, right, from the subways and things of that nature. So we are very much looking at all different parts of the world of what they're doing and trying to learn from them because it is new. And again, there's engineers or products so we're doing a lot of it, and these help a lot. Other conferences, the IDEA, things of that nature, we're getting a lot of that participation, which is very helpful because we don't have to reinvent the wheel. We're just refining it here.
Yeah, we've talked to folks across the world. Folks from across the world have come to visit our site, so we've exchanged information. I think that we have a kind of a local workforce challenge around this too, right? Like maybe in the country, there's a lot of people in the room, but think about a local energy network and what that needs. A driller, people to put in the pipe, servicing HVAC equipment. Does that exist? And then in terms of United States versus Europe, I was talking to Donovan Gordon this morning, and he mentioned Europe is ahead, and we've leapfrogged them, and now we're advancing. So I think that's a really good sign, and that we're actually taking the lead and bypassing others, even though they were first to move.
Thank you. Thank you to the panel.